Hey there, welcome back to the Database MCP series. This is part 4 of this series. Do check the previous parts before moving forward with this. In this part, we will start building the MCP tools by implementing three essential components. The query database tool to execute select queries on any database. The insert database tool to insert records with data validation and the connection pool management to manage database connections efficiently. Let's quickly review what we have accomplished in the previous parts. In part 1, we created and set up the databases that will be used by our database MCP server. In part 2, we began building the database manager by implementing logic for stabilizing connections to different types of databases, adding functionality to check whether the database connection is active, and retrieving the structure of any table so that later operations can use that information for validation. In part 3, we strengthened the safety and reliability of our database operations by implementing validation and cleaning mechanisms in our database manager. Now let's get started with building these essential MCP tools. Now we will create another method called insert with validation, and with the help of this tool, we will insert data with proper validation. But before doing that, we will first correct the name of the file because it has two S. So now it is correct. And we will begin creating this tool. We will type async, define, insert with validation. We will pass the self. Then we will write table. It should be of type string. Then there should be a data parameter. This should be of type dictionary, in which the key is of type string and value can be of any type, and this will return a dictionary. We will enter this tool, and after that, what we will do is we will write the doc string saying insert data with proper validation. Now we will create a try block to catch and handle any exceptions that might occur during execution. So let's do that. We will type try. Now we will get the table schema. Now we will write the schema, and this is assigned to await. We will call the get table schema, and we will provide the name of the table for which we want to get the schema. So this line calls the get table schema method asynchronously, passing the table name as an argument. The result will be stored in a schema table, which will be a dictionary containing information about the table's structure. So next we will write if not schema, which means if schema could not be retrieved. So in this case, what we will do is that we will return a dictionary in which the first key is success, which is set to false as we have not successfully retrieved the schema, and the name of the error because of which we could not retrieve the schema. So we will write Have string could not retrieve schema for table. And then we will provide the table name. Now, after doing this, if we have retrieved the schema, then what we will do is that first we will clean the data. So let's do that. Clean the data first. So let's do that. We will write cleaned data, which is set to self, clean, insert data, and then we will pass the data to it so that we will get the clean data. Also here, the await keyword is used to wait for the schema to be retrieved before executing the next code. So what this will do is that it will not execute the next line of code until we get the value of the schema. Now we will validate the clean data. So we will write validate the clean data, and then we will write validation errors. We will call self validate insert data. We'll pass the table to it. We'll write cleaned data, and we will write a schema. So we have created the validation errors variable. So this calls the validate insert data method with three arguments: table name, clean data, and schema. The result is a list of validation errors stored in the validation errors variable. Now we will write if validation errors. So this will check if the validation errors list contain any items, which means it contains any error. If it is the case, then we will enter this if statement and we will return success as false, error, which is the validation failed, and the kind of validation error that we have got. So we will write validation errors. So this returns a dictionary with three key value pairs. The key success get the Boolean false because we have got the error. The key error gets the string validation failed, and the key validation errors get the list of validation errors. Now, if we have cleaned the data and did not get any validation errors, so what we will do is that we will remove the null values for the columns that have default value. Now, if we insert a data and that data has the null values for some of the columns, then what we will do is that we will check the schema of the table to check if we have the default value to replace those null values. We will write a comment saying remove null values for columns that have defaults. So we will write final data. This should be an empty dictionary. So this creates an empty dictionary called final data that will store the final clean data ready for insertion. Then we will create a loop for key value in clean data items. Then we will go inside this. So this starts a for loop that iterates through the clean data dictionary. In each iteration, key gets the column name as a string and value gets the corresponding data value, which could be string, numbers, boolean, none, or other data types. Now what we will do is that we will write if value is not none. So if the value has actual data, this condition is true and we add the key value pair to the final data dictionary. So let's do that. We will write final data. We will provide the key and we will provide the corresponding value for this key. Now what we will do is that we will check two conditions. So let's do that. We will write else if key in schema and schema key. We will write default value is not none. So this checks two conditions. First, if the current key exists in the schema dictionary, and second, if the column has a default value that is not none. If the column has a default value and our value is none, we keep adding it to the final data with continue. So let's do that. We will write escape columns with defaults when value is none. And we will write continue. So this allows the database to use its default value. Else, what we will do is that we will handle all other cases where value is none and the column does not have a default value. So let's do that. We will write final data key, which is set to value. So we will add the key value pair to final data. So if the value is none and the column does not have a default value, so we will still add this key value pair to the final data. Now what we will do is that we will create the insert query with correct placeholders for database type. So different database type has different types of placeholders and we will now implement the insert query. So let's do that. First, we will check if the final dictionary is empty or not. If there is no data to insert after validation, this returns a dictionary with success key set to false and error key set to the error message string. So let's do that. We will write if not final data, then we will return the success as false and we will return the error saying no valid data to insert after validation. And if it is not the case, then what we will do is that we will add the columns variable, then we will add quotation. Inside this quotation is a comma. Then we will write join final data keys This creates a comma-separated string of column names where final data keys returns the dictionary key and join concatenates them with commas. So for example, if we have a three columns, so what this will do is that it will convert the keys which contains the column name into a format where the column names in a string is separated by the commas. So if we have a column that say name and age, so what this will do is that it will create a string where name and age are separated by a comma. For example, like this. So this is a single string in which the name and age are separated by the comma. Now what we will do is that we will use the correct placeholder style based on the database type. We will write use correct placeholder style based on the database type. So we will write if self database type, if it is a SQLite, and we will write placeholders join, and in SQLite we use the question mark as the placeholder. Then we will write for underscore and final data. So this creates a comma separated string of question marks where the list comprehension creates one placeholder that is question mark for each item in final data. Then join concatenates them with commas. Now we will do the same for the PostgreSQL. So let's do that. We will write else and we'll write it is for PostgreSQL. We'll write placeholders and we will do the same as what we did here. And instead of question mark, we will use mod s or percentage s because we use the percentage s as a placeholder for the PostgreSQL database. So what we have done is that we have created the placeholder for each item, which means the each key value pair in which the key represents the column and value represents the corresponding value. And the number of placeholders will be same as the number of columns in the table. So now what we'll do is that we will execute the query to insert the data into the table. So let's do that. We will write query. We will use f string insert into. We will provide the name of the table. Then we will write the columns. Then we will provide the placeholders. Now we will create another column called params, which is a tuple. And in this, we will assign it the values corresponding to those columns. So let's do that. We will write final data values. And then we will execute the query. We will write result. We will wait for the result before moving forward. So that is why we have used await, and then we will write database execute query. We will pass the query and params as the parameters. Instead of DB, here it should be self. And after doing this, what we will do is we will write if result success. So if we have successfully executed the query, then we will add the three new key value pairs. The first one is result validated data. So the first key is validated data, which is the final data. Then we have the original data. So we will write result original data is simply data. The third one is schema validation. Which is now set to true, which indicates that the validation was performed. And if we have successfully executed the query, so what we will do is that we will return the result. So this returns the result dictionary containing all the execution results plus the additional validation information. Now, as we have created the try block, we now have to create the exception block as well. So let's do that. We will write except exception SE. So we will storing the exception object in variable E, and this logs an error message logger error have string, and the message says that insert with validation error. We will provide the exception object which will tell us about the error, and then we will return the success as false. The error message and the schema validation, which is also set to false. So with the help of this, we have successfully created a tool called insert with validation. Now we will create a method called close. And what this will do is that it will close the database connection. So let's do that. We will write define close, and it will have self. We will write the doc string closed database connection. Now we will write if self connection. It means if the connection is stabilized. So if the connection is stabilized, then what we will do is that we will write self connection and we will write close. So we will call the close method on the database connection object to properly close the connection. Now we will write self is initialized and we will assign the value false to it. So as the database is closed, the connection is not initialized now. Now we will write self table schemas and clear. This calls the clear method on the table schema dictionary to remove all the cached schema information. Now we will write logger info database connection closed. So this logs a message with a string database connection closed. So this indicates that the database has been closed. Now with this, we have successfully created our database manager class. Now what we'll do is that we will initialize our MCP server. So let's do that. We will write initialize MCP server. And after doing that, we will create a variable called MCP, which is an object of fast MCP class. Inside this, we will give the name of this MCP server, which is database MCP server. So this creates a new fast MCP instance with the name database MCP server, and it assigns to the variable MCP. Now we will create a dictionary that will store the database connections. So let's do that. We will write global connection pool because this is a global variable or global dictionary. And we will write connection pool and sample database path. So here we will provide the path of the sample database. Here we have sample database.db. We will copy the path. It is not copied properly. So we will do that again. Now it has been pasted. So we have provided the path of the sample database. Now we will create a function called isSampleDatabase, which will determine whether a path points to the sample database or not. So let's do that. We will write this should not be inside the class. And now we will create the function. We will write define is sample database. This will take a string parameter database path. and this will return a Boolean value. We will write a doc string saying determine if a path points to the sample database. And then we will return OS path, absolute path, and we will pass the database path to it. So absolute path means a path like this is a complete path where this sample database file is stored. So this is the absolute path, and there is something called relative path, which simply means this part of this whole absolute path. So relative path will contain only the sample database.db, and absolute path will have this whole address where this sample database is stored. And then we will check if it is equal to the OS path, absolute path, sample database path. So if the database path that we have provided is equal to the sample database path, then it is a sample database. Now we will define the asynchronous function, which will get or create a database manager for the specified path. And we have created the asynchronous function before like this. Uh, so this is a asynchronous function and not a tool. I might have referred it as a tool mistakenly, because for tool we have to define a decorator like this. And as we have defined this, then it will act as a tool. But this is not a tool. This is a asynchronous function. So we will create the another asynchronous function here, and it is called asynchronous. Then I will type define get database manager database path, which should be of type string, database type, and it should be of type string. We will write SQLite as a default value for the database type, and then connection string, which should also be of type string, and it will be set to none, and it will return the database manager object. So we will write database manager, and we will enter this asynchronous function. Now we will write the talk string get or create a database manager for the specified path. Now we will create a unique key for the connection. We will write the comment create a unique key for the connection. Then we will write connection key, which is set to f string database type, and database path. So this creates a unique identifier by combining the database type and database path with a colon separator using string formatting. So for each connection, we will create a unique connection key. We can also assign a random value to it if we want to make it more robust. But currently, we will keep it as it is. Now we will write connection key in connection pool. This checks if the connection key exists as a key in the connection pool dictionary. And if it is the case, then we will retrieve the database manager object from the connection pool using connection key as the key and assign it to the manager variable. So let's do that. We will write manager connection pool, and then we will provide the connection key. So with the help of this, we will retrieve the database manager object from the connection pool using the connection key. Now we will call the isConnected method on the manager object. We will write if manager is connected, then we will return the manager. So if it returns true, which means if the manager is connected, then this will return the existing manager object. Otherwise, we will write else and we will remove the dead connection. So remove that connection. And to do that, we will write manager close, and then we will delete connection pool and provide the connection key. So this handles the case when the manager is not connected by calling the close method on the manager object to clean up the dead connection. Then removes the key value pair from the connection pool dictionary where the key is connection key. Now we will create a new connection. So what we will do is that create a new connection. We'll write manager as a instance of the database manager class. We will provide database type, database path, and connection string if provided. Then we will wait for the manager to be initialized. So this creates a new database manager instance with the provided parameters and assign it to the manager variable. And then this will call the initialize method on the manager asynchronously to set up the database connection. Now we will write connection pool, then connection key, and it is set to the manager, and then we will return the manager. So this adds a new key value pair to the connection pool where the connection key is the key and the manager is the value. And then it returns the newly created and initialized manager object. Now we will create our first database MCP tool, and this tool will execute a select query on any database. So let's do that. First, we will define the decorator. which is MCP tool, and it means that we are now going to create the tool for the MCP. So we will write asynchronous define query database path of the database query parameters as optional list with default none. So let's do that. Limit, which is of the type integer, and it is set to 100. So limit is the maximum number of results to return. Now we will write the database type. It should be of type string, and it is set to SQLite. Then we will write the connection string, which is set to optional string. Then we will write connection string. It should be of type optional string, and it is set to none. We use this for the PostgreSQL database, and this will return a string value. Then we will write the doc string saying execute select query on any database. And we will enter the try block. So what we will do is that first we will validate it's a select query, and to do that we will write validate its uh, select query. If not, query strip lower and starts with select. So after stripping white space and converting the query to lowercase, this checks if the query does not start with select. And if it is the case, then we will return JSON dumps and then a dictionary type object. We will write status error. We will write error only select queries are allowed with this tool. And we will provide the indent as 2. So this returns a JSON string created from a dictionary with two key value pairs. Status key gets error string and error key gets the error message string. And with indent set to true, we are formatting the JSON with two space indentation. Now we will write database, which is set to await. We will call the get database manager function. We will pass the database path, database type, connection string. This calls the get database manager asynchronously with the provided parameters and assign the return database manager to the database variable, which is DB. Now we will write query parameters, which is params, and this should be a tuple. Params if parameters else none. This uses a ternary operator where if parameter exists, it converts it to a tuple and assigns to a query parameters. Otherwise, it assigns none. Now we will write result await database execute query. We will provide query parameters, and then limit. This calls execute query method on database object asynchronously with query parameters, and limit as keyword argument. This will store the result in result variable. So with the help of this, we will execute the select operation. Here limit is the maximum number of results to return. So the result may contain millions of data, but we will provide it a limit, which is the maximum number of results to return, and then it will return that number of results. Now we will write if result success, and we will enter this. So if we have successfully executed the result, so the value of the success will be true. And if it is true, then we will return JSON dumps status as success, database path as the database path is sample database, which is set to is sample database path. We'll write count, and its value will be the count from the result dictionary. We will write data, which is again from the result dictionary. Now we will provide the indent as 2 and default is set to string. So JSON supports specific number of data types. And if there is a data with a different data type which is not supported by the JSON, then the JSON will convert this data to string data type. Now we will create else statement, and this will return JSON terms status as error. This should be a string, and then database path, which is set to database path, and then error, and it is set to result error. We will provide the indent, which is set to true. So if we are not able to execute the query successfully, then it will execute this else statement. And if we get any error in this code within the try block, then what this will do is that this will call the except block. So we will write except. It should be aligned with the try block. And we also have to define the exception as E. And this will return JSON terms. We can simply copy this instead of this result error. We will provide a string and exception object. So this will catch any exception from the try block and stores it in the variable E, and then returns a JSON string from a dictionary with three key value pairs. Status gets error string, database path gets the path of the database, and error will get the error message. Now we will create another tool called insert into database validated, and with the help of this we will insert a record into any database with proper validation. So let's do that. We will first write the decorator, which is MCP dot tool. After that, we will write asynchronous, define, insert into database validated. We will provide database path, which should be of type string, and then table, which is again should be of type string, then data, which is a dictionary, database type, we will give it the SQLite value. Then we will write the connection string. This will be of type optional string. Currently it is set to none. So here optional string means that the value can be of type string or it can be none, which means that null value. And then we will write validate data, which is of type boolean, and its default value is true. This will return a string value. Now we will write the talk string saying insert a record into any database with proper validation. Then we will add try block, we'll add database, await, get database manager, database path, database type, and then we will provide connection string. Now we will write if validate data, then we will write the result which is set to await database insert with validation, and we will write table and data. So what it is doing here is that first it will call the get database manager asynchronously with the provided parameters and assign the returned database manager to the database variable. That is what we are doing here. And after that, this code checks if the validate data is true. And if the validation is enabled, this calls the insert with validation method asynchronously on the database object, which is DB object. Here we are passing the table name and the data dictionary, and then the result will be stored in the result variable. After that, we will create else statement. We will use the original method without validation. So if the validation is disabled, then what we will do is that we will write columns join data keys. So from the data, we will get all the column names and we will separate the column name by the comma. So this will create a string where the column names are separated by the comma. And after that, we will write placeholders. And we will write join the placeholder for underscore in data. So for each item in the data dictionary, we will create the placeholder. Now we will write query insert into table, which is the name of the table, then the column name, and the data that is needed to be insert. But currently we are using the placeholder. Now we will write the params to get the data that is to be inserted into the table. So we will write data values. So with this, we will get the values for each column. Then we will write result, await, database, execute, query. We will pass the query as well as parameters. So this creates a comma separated string of column names from the data dictionary keys. And this creates a comma separated string of question mark placeholder with one question mark for each item in the data dictionary. And then we will create the SQL insert query using F string formatting where table, column names, and placeholders are substituted. In the next line, we are creating a couple of parameter values from the values of the data dictionary. And in the next line, we will call the execute query method asynchronously with the constructed query and parameters. Now we will check if we have successfully executed the query. So let's do that. We will write if result success. So if we have successfully executed the query, then the value of result success will be true. And if it is the case, then we will write response, which is set to a dictionary where status is success, and then database path is db path. It should not be a string, it should be a variable. And then is connected, is sample database to check if it is a sample database or not. So we will give the sample database function and pass the database path. Now we will write the message, and here it is record inserted into the following table, which is the name of the table. Now we will write the affected rows, which means the number of rows that are affected after inserting the table. So if two rows are inserted, so the value will be 2. And if three rows are inserted or deleted, then the affected rows will be 3. So let's do that. Result affected rows. And after this, we will write last insert ID. And we will write result get last insert ID. And then what we will do is that we will check two conditions. That is, if the validate data is true and if the validate data key exists in the result dictionary. So let's do that. We will write if validate data. So if the data is valid and if the validated data is in the result, then what we will do is that we will write response validated data, and it is set to the result validated data. After this, we will write this fonts original data, and then we'll write the result original data. So if both these conditions are true, then this adds two more key value pairs to the response dictionary. The validate data key gets the validate data from the result, and the original data key gets the original input data from the result. And then we will return JSON dumps response and indent is set to 2. So this returns a JSON string representation of the response dictionary formatted with 2 space indentation. Now we also have to write the else condition. So we'll write else. So if the result is not success, which means the value of the result success is false, then what we'll do is that we will write error response. It is a dictionary status is set to error. Database path is set to database path. Error, and we will assign it the error that we have got. And if the validation errors is in the result, then we will write error response validation errors, and it is set to result validation errors, and then error response validation failed, and it is set to true. So this checks if the validation error key exists in the result dictionary. If validation errors exist, this adds two more key value pairs to the error response dictionary. The first one is validation errors key, which gets the list of validation errors from the result. And then we have validation failed key, which gets the Boolean value, which is set to true. Now we will return the result, return JSON terms, and then error response and then set to true. So this returns a JSON string representation of the error response dictionary. Now for the try block, we also have to create the exception block. So let's do that. We will write except exception as E. So we will create the object for that exception, which is E, and then we will write JSON dumps. We will create a dictionary, write status, error, database path. We will write the database path, error. We will add the error message, and then this indentation is set to 2. So if we get any error in the try block, this exception will execute. There is some mistake in here which we have to correct. So here it is parenthesis, and we have provided the double curly braces instead of parenthesis. So now it is correct. This concludes part 4 of the database MCP series. We have now started building the MCP tools that transform our MCP server into a fully functional server capable of handling real-world database operations. Today, we implemented a connection pooling system that efficiently manages database connections and automatically handles connection cleanup. We implemented a secure query tool that restricts operations to select statements only. We built an insert tool with schema validation that checks data types and constraints, and we performed error handling with detailed JSON responses that make debugging and monitoring straightforward. In the next part, we will expand our toolkit with more database operations. We will implement update and delete tools with safety mechanisms. We will implement table discovery capabilities and validation testing tools that demonstrate our data integrity features in action. If you need help with your projects, have difficulty learning these concepts, or want to deepen your understanding of how things like this work, Codersarts is here to support you. We offer personalized project assistance, one-to-one live sessions, help with building AI-related applications, and full development and deployment services. Visit us at www.codersarts.com or reach out directly at contact@codersarts.com. You will also find our LinkedIn, Instagram, and Facebook handles linked in the description box below. Thanks for watching, and don't forget to like and share the video and subscribe to the channel so you never miss out our latest tutorials. Thank you.